For over 50 years, ESA has led Europe's journey into space. And for 5 decades, one network has kept us connected to rockets, satellites, planets, and the cosmos. Estrack is ESA's global network of ground stations. Each one keeps us connected to spacecraft. From liftoff through low Earth orbit and far into deep space. Estrack's story began in Spain. In 1975, we set up our first antenna in Villafranca, near Madrid. It marked the beginning of Europe's autonomous link to space. From there, the network grew. New antennas expanded our reach across all orbits, supporting European launchers with dedicated tracking systems. In 2003, Estrack went beyond Earth. ESA built its first deep space antenna in Australia, then a second in Spain, and a third in Argentina. Together, they formed 360-degree coverage for deep space exploration.
We are just about to inaugurate our 4th deep space antenna in New Norcia, Australia, and are planning the 5th one also in South American longitude. Our deep space antennas are not static colossus of concrete and steel. They embed a large number of highly sophisticated technical equipment, cutting-edge technology that we keep on improving to increase the performance of the station. We move continuously to the higher bands, adoption of Ka band, 26 GHz to address the needs of the Euclid mission.
Today, the network spans 6 stations across 3 continents and link back to ESA's mission control in Darmstadt, Germany.
ESOC is in charge of managing the ground segment for our missions, among those the Estrack stations around the globe, and we operate the stations as an essential part of our end-to-end mission operations.
Here, teams work around the clock. Engineers, scientists, mission controllers, even astronauts. All of them play a role, working with pinpoint precision 24/7.
So Estrack is an essential capability for ESA to operate the spacecraft from our mission control center here at ESOC. Estrack is serving all types of missions that ESA is flying: Earth observation missions, interplanetary missions, scientific missions, more and more space safety missions, and lunar exploration. As ESA ambitions grow, Estrack has to grow too. And that's why we are building the New Norcia station in Australia. The New Norcia station will provide us with 2 stations at the same location and the same longitude in Australia, allowing us to provide more capacity to our missions, to do arraying services, so enhance again our capacity, and also increase our availability and resilience from this side.
Estrack powers ESA's most ambitious missions, from Mercury to Mars, Jupiter, and beyond.
Estrack is so important for ESA and for Europe because it's Europe's global network of ground stations, allowing us to communicate with our world-class, cutting-edge missions many millions, even billions of kilometres away. We use this ground station network to send our critical commanding, keep the satellites safe, and also to downlink their very valuable science data. World-class missions need world-class infrastructure, and our ground segment engineering and operations team take care together to develop and operate these very complex systems.
But Estrack isn't just ESA's link to valuable science. It's a tool for global collaboration, supporting partnerships with space agencies and even commercial space flights around the world. As our missions grow more complex, Estrack is evolving. In 2025, a new deep space antenna will join the network, with more on the way. Looking ahead, new technologies are on the horizon. Laser communication could boost data transmission by a factor of 10, or even 100, helping us meet the growing demands for next-generation missions. And one day, these breakthroughs could enable a seamless connection between networks on Earth, the Moon and Mars, the first step towards a solar system internet.
So the key reasons that ESA builds deep space antennas on Earth is so that we can bring data back from our iconic science missions and also to send instructions up to those satellites that are in deep space. And the ESA Science Programme aims to answer some of the biggest questions that humanity has to ask. Are we alone in the universe? Is there life out there? How does the cosmos work? What is the nature of the laws of physics in the universe? And so we have missions that study everything from our own sun all the way out to the nature of space-time in the future. The Deep Space Antenna Network is critically important for bringing the data back from those satellites that are sensing the nature of the universe to our scientists across our member states and our international collaborators, and also for sending the instructions out to those missions, particularly the ones in the solar system, to tell them where to fly, how to fly, and what to do next.
Estrack has always been Europe's bridge between Earth and the stars, and now it's heading into the future at the speed of light.